Welcome back. So I know I originally said we would be using Effect AI, but we're actually going to build our own simple version instead. And the reason for this is twofold. First, it is a much better way for us to actually learn the effect mental model. And second, it protects our series from breaking changes while the official library is still somewhat experimental. So let's jump right into it. So what we're going to do is create a directory under source and under lib for the server package, and this will be called AI. And here we're going to create an AI model.ts file. Now here we're going to define the tag for different AI models. So this could be from different providers like Google versus Anthropic versus OpenAI and so on. So this will ultimately be the main interface. So for this, we're going to say export class AI model extends, and then we're going to use effect.tag. And here we say the ID will be, and let's prefix this with org just to make sure there are no collisions. And then say this will be AI model, and then we must pass in the reference to self. And then here we define the actual service interface, and we need to close this off. So the reason we're using effect.tag as opposed to say context.tag is because this gives us accessors for the properties, which means that we can say AI model.generateText, for example. With context.tag, you wouldn't have this. Anyway, so with this, let's define the actual service type. So we can say export declare namespace, and this will be AI model. And the reason we're using declare is because this will only be there for the types. This will not be a runtime namespace. And here we can export a type, which is service. And we're going to have three methods. We're going to have generateText, streamText, which will give us a stream back, and then generateObject, which is going to give us the decoded or the output type of the passed-in schema. So let's start with generateText. This will be a read-only property, and here we're going to take in some options, which is going to be the prompt and optionally a system prompt. And we're going to give back an effect that will succeed with a string and will fail with an AI error, which will be our all-encompassing error. So we're going to create it here, export class AI error extends, and then data.tagged error. That way we can yield this error without wrapping in effect.fail and whatnot. And this will contain the original error, which will be a cause of unknown, and this will help when logging the error. Then a description, which is a string, then the method. So for example, generateText, streamText, etc. And then the module. And this will be a string. And here we can provide our custom message property, where this will be the this.module, not method, with the method and then the description. And now we can say generateText will fail with this error. And for now, let's say this will be AI model.service. And I forgot to invoke this again. Great. So now let's move on to streamText. And this one again will take in options, which is going to be a prompt, then a system prompt. And here we're going to take in a schema, which is an optional schema. And here we actually need to preserve the generics from the schema. So we need to say A, which is the decoded type or the output type of the schema, then I, which is the encoded or input type of the schema, and then the requirements of the schema. This way we can say schema.schema, A, I, and R, and this will return a string that will succeed or give you back a string. It is going to fail with AI error, and it will require the same requirements as schema. And And finally, we need the generateObject method, which is pretty much identical. The only difference is this returns an effect that will succeed with A, so the output type. And that's pretty much it. Awesome. So now with this, we can move on to defining the actual providers. So for this, I'm only going to support OpenAI and Google AI, but this will set a strong foundation so you can start adding more models. So in this case, I'm going to add an OpenAI provider.ts file. And here, we're going to create a tag specific to this provider in such a way that when you try to use a model from OpenAI, it is going to logically require this base configuration, which makes you pass in the API key, and we're internally going to construct an HTTP client that sets everything for us. So we're going to say export class, then OpenAI provider, and then this will extend that context.tag this time. And here we're going to apply the same structure. So declare namespace, OpenAI provider, and then service. And here we're going to have the HTTP client, which comes from @effect platform, and then the API key, which will be a redacted string. Now this has a generic, as we can see here, where by default it is a string, so there's no need to type it out for redacted. And same thing here, we can say OpenAI provider.service. And now we need our make function. So this will be an effect.function untraced, and this will take in the make options, which will be a read-only API key, and same thing, redacted. And now here we can construct the client. So HTTP client is equal to yield HTTP client.HTTP client, which means that our make function now requires an HTTP client implementation. And now we can wrap this up in parentheses so that we can compose it here. And we're going to say HTTP client.retry transients, though perhaps this can be passed in by the user, but for now, let's do it like this. Schedule, and then this will be a union of recurse 3, though this has a times property, so we can simply say schedule.exponential, and then we can start with 200 millis. And then we can say HTTP client.map request. We get the request here, and thus we can pipe it here saying HTTP client request.prepend URL, and this will be https api.openai.com. And then we can say HTTP client request.bearer token. And here this takes in a redacted, as we can see, either a string or a redacted. So we can simply say make options.api key. And finally, we need the set header for content type to be application JSON. And now we can return and do OpenAI provider dot off, which is going to add the underscore tag for us, so we can skip doing this. And we pass in the HTTP client and then the API key. And now we need the layer version of this make, because this will be an effect. So what we can do is say export const layer, then make options, and then read only API key, same thing, a redacted. And here we're going to return a layer.scoped of OpenAI provider, and we pass in make with the make options. Now the reason we are not creating a type for make options so that we can reuse it at both make and layer is because that doesn't give the best developer experience. So notice how if I hover over layer, we can see the type here. But if I were to say make options and then replace it here, it is now this opaque type. Not sure if you can configure this at the ID level, but this will do. Okay, great. So now we can move on with the actual implementation for the model. So in this case, we can create a file, OpenAI model.ts, and here we're going to have a couple of things. We're going to have the open or the JSON schema utility so that we get structured outputs. We're going to have the schema definitions. And finally, we're going to have the actual implementation. So let's say implementation. So let's start with the basics. So we need the model type. For this, I'm just going to say GPT-5 or GPT-4o or O-mini. And well, we can later add more here. And here we're going to export a make function, which same thing will be an effect. And this will be an untraced function. And we're going to say again, make options. And this will take in a read-only property for the model. And here we can yield the config. So yield OpenAI provider. That way, again, we get access to the HTTP client and the API key if we need it. And now here we can return AI model dot and then off, and we can for now do an effect dot die message not implemented. And for the stream, well, this could be an effect dot die message or a stream dot die message. So let's start with the most basic one, which is generateText. So here we're going to have an effect.function, and we're going to get access to the options. And this actually doesn't need to be a generator, so we can just return an effect right away. And this will be config.http client, and then we can do a post to /v1/responses. And here for the second argument, we can pass in the body, and this will take in an HTTP body. So we can import this from @effect platform and then say unsafe JSON. And here we pass in the model that we want to use. And now OpenAI requires this input array. So you can say role, and this will be user, and the content will be the prompt. And then we can check, is there a system prompt? If so, then pass this as system and then the system prompt. And with this, we can now come here after the post, pipe it through, and then we can say flat map, and then HTTP client response.schema body JSON. And this will be a completion. So we can come here and say class completion extends schema.class. And this will have a literal, which is response. And then the output is a schema.array, which I guess in this case it's going to be a tuple, but let's leave it as an array for now, of objects of what? A literal type, which is going to be the message. And then the content will be an array of objects of schema.literal, and then output text, and then the actual content. And so we can now pass it in here, and this will automatically parse the JSON response with this schema. And with this, we can now do an effect.map, and we extract the content. So let's actually type this as a tuple, and then we can see if this is going to fail for some reason. That way we can access it like this without any silent fallbacks. And we can do a map error, and we get the error here, and we can say new AI error, and then the description will be the error.message. Then the method will be for generateText, then the module will be an OpenAI model, and then the cause is the error itself. And that's pretty much it. So pretty straightforward. Now, as for generateObject, let's do the streaming one last. Here we can say same thing, effect.function. I just noticed this doesn't have a span. Should probably have one. So this will be OpenAI model.generateText. Same thing for this one. And here we're going to say config.http client.post. Same thing, v1 responses. And then the body will be http body.onSafeJSON. And same thing, we pass in the model, we pass in the input. So this comes here, options. And then we need to pass in a text property which has a format. And here we can say this will be a JSON schema. Then you need to provide a name and then the actual schema. Now in this case, OpenAI requires, I believe, the JSON schema v7 spec. So fortunately, we can say const make JSON schema, and then we have decoded, encoded, and the requirements. And this will return a JSON schema dot JSON schema 7, and this will be JSON schema dot from AST schema dot AST, and then definitions target, which is JSON schema 7, and then top level reference strategy. I believe this will be a skip. And with this, we can now come here and say make JSON schema of options.schema. And now we can pipe this. We can do a schema body JSON with completion. We map over this, and then we can say flat map schema dot decode and then schema dot parse JSON. So this will deserialize the JSON for us, and we're going to pass in options.schema. And then for the error, well, same thing, but in this case, the method will be generateObject. Okay, great. So now let's implement the streamText method. So here we're going to do the same thing. So a function OpenAI model.streamText, and here we're going to do a normal post request. However, we're going to pass in for the body the stream true flag, and here we can actually copy our text property from generateObject into this one conditionally via options.schema, and then we can pipe through these again, though in this case we can say client response.stream. So we can come here and say decode text, and we can import stream, and this will be UTF-8 encoding. And then we can split the lines, so by new line, as we can see here, and then filter the line where it starts with data. So this will correspond to the server sent events convention or spec. And here we can filter out the lines where it is different from done. That way we only process the actual lines that come in with the real chunks of content. And with this we can slice the line, so line.slice 5, that way we get rid of the data prefix, and this is actually just data without a white space. And then we can do a map effect. So for each chunk we're going to decode this using schema.parseJSON, and we're going to pass in a response event schema. Now this schema is a little bit more intricate, so I'll just copy and paste it here, but in essence it has all of these properties which we do not really need, so we can trim this down. But the point being, it has a response property which comes in with the output, giving us the text. So in fact, when you have a union of literals, you can refactor this by using multiple arguments instead. So that's looking much better. And with this, we can now filter the event where the type is equal to response.output text.delta. And finally, we can map the event to extract the delta. and we can then say stream.mapError. So if we come across any type of error, again, we're going to remap it over into an AI error. And this is pretty much it. Now, the reason we're getting this error is because effect.function expects an effect, not a stream. So we need to turn this into a normal function instead. And that way, as we can see, the error went away. However, we can still instrument this by saying stream.withSpan and then OpenAI model.streamText. And now we need our model function. So export const model, and we take in the model here, and we simply call make and pass in the model. So with this, we can now import everything as OpenAI model, or we can have a namespace for this, and then you would say OpenAI model.model. And then GPT-4o, for example. Anyway, with this, we can now test our implementation. So I'll create a test.ts file here, and we're going to say const OpenAI live is equal to layer.scoped, and I'm actually going to create an index.ts file, which is going to re-export everything. So export all as AI model, OpenAI provider. That way we can say OpenAI provider dot, and then OpenAI provider dot. Do we have a layer? Yes, we have a layer. We can just say OpenAI provider dot layer, and then the API key. Well, let's use process.env for this, and let's say it's defined, and we need to wrap this up into a redacted, and we're getting a type error here saying argument of type string is not assignable to a redacted of a redacted. So not sure. We're passing value, not make. Okay, and notice how this layer will now require the HTTP client. So we can pipe this and say layer.provide fetch HTTP client.layer. And now we can define our to-do, for example, schema.class for a to-do. And then this will have an ID, title, and completed. And then we're going to have our main program, which will be a generator function, and we're going to yield the model. So OpenAI model, and then we can say GPT-5, and then we can get the text. So yield model.generateText, and here we can pass in a prompt like what is the capital of France, and there is no need for a system prompt. Or well, let's let the LM to write the prompts for us. And with this, we can console.log the text. And then let's have a to-do generateObject. So create a random to-do item. And finally, we have the stream. So for the stream, we can do a console.log new line, then stream. And then we can yield a stream.run for each. And let's actually do it the other way around. So model.streamText, and then write a poem about the color blue. And let's say stream.run for each. We get the chunk here, and then we can use console from effect and say log chunk. Now the reason we're using console is because this requires an effect, as we can see here. So you must return an effect. So we could either use an effect.sync and then internally a console.log, or well, just use the console module instead. This should theoretically work. However, we need to say main.pipe and then effect.provide OpenAI live, and then I believe this is it, effect.run promise exit, or just promise, and we're getting a type error because we're getting unknown for the requirements. So something is giving us unknown. This works. Or what about, so it is a stream text. So let's come here. What might be the issue? All right. So since we're not passing a schema, it is going to default to unknown. So we can say this will be by default never, and now it works. So let's add void and we can run this file. So I'll copy the relative path and then use bun to run this file. So I pass in my env file, which is the .env at the root of my file or my directory. And for this, I'll use bun. So I pass in the env file and then the path to this file. And well, let's see what happens. So it seems to be the tuple. So let's actually come back here and say this will be an array. And let's do a fallback to an empty string. Same with generateObject. And then let's rerun this. And okay, so this is a reasoning model. So let's actually use a non-reasoning model. I guess GPT-4o is not reasoning, but to be honest, I have no clue. Okay, as we can see, we in fact get the text. So the capital of Francis Paris, then we get the to-do, decoded properly, awesome. So the structured output is working and then we get the stream. So if we change this to be a run collect, we should get back the string, a chunk of a string here. So we can actually do a run fold and then simply add the accumulator with the chunk, and then let's do a console.log stream, and then let's try it out again. So it is taking some time, obviously, and we get back this really nice poem. Okay, great. So with this, we pretty much have our OpenAI integration. In the next video, we're going to resolve the thinking issue, and I'm going to show you the Google AI integration. And then the one after that, we're going to create our RPC so that we can start generating stuff and streaming in the generations to the client. Anyway, I hope you learned a lot in this video. If you have any questions, feedback, whatever, let me know in the comments. I'll see you in the next one. See ya.